Hi everyone. I continue. I continue on the lesson. So, after all of those percentages that we did, so now we are going to talk about percent concentration. So when we have a solution and we want to see what is the concentration of a substance in it. For example, I can have salt and water, and that solution can be mixed together, and I want to know what is the concentration of, for example, so salt. Okay, what is the concentration, or how concentrated is my coffee, for example. So I want to see. So we want to measure those. Okay, so we need to before we move on to any questions and any example, we need to know some definitions. So we have solute, which is the substance that is being dissolved. Okay, so in a in a solution. Okay, so for example, like sugar. Okay, and solvent is substance that is doing the dissolving, for example, water, and total solution is the summation of both of them together. Okay, in general, the following equations applies to a mixture of two or more substance, and I want to know, for example, what is the concentration of of the substance inside the solution. Okay, so here, for example, the formula here is this, and I think you know that if I want to know what is the concentration, for example, of one thing inside the solution, I have to have the amount of one thing. That's the part here. That's like the part. That's the part, and that's over total. Okay, over total, and percentage over 100, and then I can find how many percentage. So I need to know the amount of solute, for example, the amount of the one that I need to find the concentration of that. Okay, so the amount of that, which is part, over total amount, that's the total mixture all together, makes sense because it's part over total, and then how many percentage over 100. Okay, so let's do some questions. Suppose that you have 20 gram of sugar and it's dissolved in 165 gram of water. Calculate the percentage concentration. Here you have to really pay attention that what is part, what is total. Okay, the part is, so concentration, percent concentration, and we have to say percent concentration of sugar here is needed. Okay, so part over total. So it's 20 plus 165. It's x over 100, and then you can find x. Okay, so it's x over 100, 20 over 185, and then x is 10.810 repeated. Okay, and then I can round to 3 significant digit. So here I do that, so it is almost 10.8%. Okay, W over W, weight by weight, because both of them are weight. So weight is for total, it's gram, and this one is gram plus gram, so it's gram as well. Okay, so gram, so weight over weight. Okay, mass by mass. Okay, so that's the concentration of the sugar. So calculate the mass of salt that must be dissolved in water to prepare, read the question carefully, to prepare this of 7% solution. Remember, it says prepare this of solution means this is total. That's total, and that's by gram. So okay, so here what is missing? Percentage is given, total is given. I'm looking for part then. Okay, so it is 7 over 100. How many over this? I don't need to add because I know that's total. But there, I don't know that's total. I have water and sugar separately. So I have to add them. So here, so it is x is 35 gram. Okay, that is that based on the number of significant digits that you see, you can have this 3 significant digits. Okay, so this gram of salt. Okay, don't forget you need a conclusion sentence. You need to add conclusion sentence here. You need to add conclusion sentence. These are word problems. You need to add conclusion sentence. Okay, so here I can say, in order to have 7% solution, we need 35 grams of salt to be dissolved, to be dissolved and make this many grams of solution. And read the question carefully. Which one is part? Which one is total? Okay. So if you have two parts, part and part, you have to add them to make total. Okay. So be careful with that. So calculate the percentage of butter. Calculate the percentage of butter in an icing recipe that requires this milliliter of butter, this milliliter of milk, this milliliter of icing sugar. Here I have 3 items. Doesn't matter. I am asking percentage of one of them. Percentage of B. Okay, so percentage of B. Calculate percentage. So X over 100 equal 80 over milliliter. I have to be careful with unit. All of them are milliliter, so I can add them. Easy. So 80 milliliter plus 70 milliliter plus 650 milliliter, which is X 8 over 8. So that's 10%. That 10% V by V, because it's volume over volume, because both of them are milliliter. Before I had gram and gram, so it was weight by weight. Okay, so make sure to add the sentence here. So now, in chemistry, a solution is mixture in which one substance, which is the solute, is distributed in the substance, another substance which is solvent. The same as sugar in water, salt in water. Okay, concentrations are often expressed as percentage. Okay, so mass by mass, because both of them are mass. I have part mass and total mass. Or volume, V by V, because both of them are milliliter, liter, both of them are by volume. Or W over V. So, for example, salt or sugar in gram, but in solution, I am talking about the volume of the solution. Okay? So, we can have also part per million. We can have molarity. So for those, I'm going to explain for those green ones. So I explain when we move on to the topic. Okay, so percentage W over W, the same as we did in the question. I have solute, which is part. Here, weight of by weight, gram, kilogram, or those things. Total solution, that's total. And then it will be percent over 100. So this percentage is W over W. Okay, a student is asked to prepare 450 gram of 15% W by W KCl solution. How to do it? How we can do this? How the student is going to do it? What is the way? Okay, so what is 450? 450 is total. 15%. Okay, so it is 15% over X over 450. Because that is just missing. Okay, so X is 15 multiple 450 divided by 100, which is 67.5 gram KCl. Okay, so I have 450 gram as total. I have that gram as part KCl. Okay, so I can say, therefore, I mix 67.5 gram of this with 450 gram minus 67.5 gram, which is 382.5 water. Okay, easy, because one of them is gram, total is gram, so I can find how much water. Okay, so this is how much water here. Okay, so the next question, I can have V over V. So part is in volume, total is also volume. Okay, so a student is asked to prepare 450 milliliter 15% V by V ethanol solution. So how to do it? So how does the student just have to do this? Okay, so what should we do here? What should be done? So 15% X over 450. Sorry, milliliter. Okay. Yeah. So X is the same as the other question. I can calculate X, and X is 67.50 milliliter ethanol. Therefore, I can say I add 67.5 milliliter ethanol plus 450 milliliter minus 67.5 milliliter, which is 382.5 milliliter water. Okay, can be that. Okay, or if you can use another solvent, yes, you can. So it's just it depends on what you can do. Okay, so I'm not going to talk about that part. Okay, so here I can say 67.5 milliliter ethanol plus top up to 450 milliliter with water. Okay, so it's like I have something like this. I add 6, for example, 67.5 milliliter, and then I just add up to 450 solution, 450. So I just add the water up to here. Okay, so I add it and then I fill it until I reach to 450 milliliter, and then it will be solution because it's ethanol and also the solvent, so will be added together to make the solution. Okay, so that's the sentence here. Okay, so now W over V, when I have part as gram and I have total as milliliter, liter, so just volume. Okay, so how do we do this one? this is a little bit tricky. Okay, so let's do it. A student is asked to prepare for 50 milliliter, because I said total is in milliliter or total is in volume, of this percent W over V. In this case, I need to know the density. So the density of KCl, how much gram I have per milliliter. Okay, so how can I change weight to V, weight to volume? How can I change? How can I go from W to V? Okay, so let's see. First, step by step, 15 over 100. Okay, doesn't matter. W over V. Yes, perfect. So X over 450 milliliter. Okay, so X is the same as before, 67.5. 67.5 gram KCl. So far, so good. Because the percentage is also W over V. Okay, the percentage is also that. So I say, okay, this is also weight. So gram is here. Okay, so I can say I add this 67.5 gram KCl and then top up to 450. So that's in grams. So maybe it's a powder, for example. Okay, for example, and then I add on top of it, I add water until I reach to 450 milliliter with water. Okay, or any solvent you can do, you can use. Okay, so yeah. So I want to ask a question here. Can I say I add 67.5, so I have 67.5 gram plus 450 minus 67.5 of water. Which is 2.5 water. Can I do that? The answer is no. Because one of them is gram, one of them is milliliter. Sorry. That's milliliter. That's milliliter here, and that's gram. Okay, this is not correct. So what should I do here? So this question is not the same as others. The first question was W and W. The second question was V by V. But here I have W and V. So I found KCl in gram. I want to change it to milliliter. So I need to use density. So 67.5 gram KCl multiple. I want to cancel gram and I want to bring how many, what is the volume of this? Okay, so 1.98 gram KCl 1 milliliter. So 1 milliliter is equivalent to this many gram. Okay, I cancel this and that. This is 34.09 repeated, or maybe almost 34.1 milliliter KCl. This is not 67.5. No, it's 34.1. Okay, so if I do 34.1 milliliter plus 382.5 milliliter water, then it will be 4 6.6 milliliter, which is much less than 450 milliliter for total. So this doesn't work. Okay, what I did for question 1, as I said, 67.5 and the other 382.5. It works there because I have for both of them W, for one of them both W, for one of them both V. But here is W and V. Part is W, total is V. So I cannot say that. Okay? So this is not correct. So the correct answer is this. 67.5 gram KCl plus 450 milliliter minus 34.1 milliliter. I changed KCl to I just find out the volume and then I subtract volume, because when I add, I should have the same unit, both G, both ml. Okay, so here both milliliter. So this milliliter, this together, which is 67.5 gram KCl plus 415. Let me see here. 415.9 milliliter water. Okay, and then let me see, am I right here? 450 minus 34.1. Yes, water. And then this is done. Okay, the next, part per million. For something like, for example, the level of mercury in tuna, it should be very small. So the concentration should be very, very small, because if you have more mercury, so it's not healthy. Okay, so in these questions, I can talk about part per million, because per 1 million, okay, I can have a number which I can consider. Okay, the total part must be very large, so I consider it as 1 million instead of 100, for example. Okay, so part over total one side, and the other side part per million over 1 million. So I'm not talking about 100 here. I'm considering the total as million. Okay, so the level of mercury in contaminated tuna is this. And what is part per million? Gram or milliliter or whatever million I have, the part is also the same. So here it says the level of mercury in contaminated tuna is 1.05 part per million, means 1.05 gram per 1 million gram, or 1.05, for example, kilogram per 1 million kilogram. Do you know what I mean? So the top and bottom are the same. The part, so I don't need to say what. So it depends on the question. I don't need to say what here. Okay, so in this question is gram. So the level of mercury in contaminated tuna is this. How much mercury is in 500 gram tuna? 500 gram tuna is total. Okay, so 1.05 over 1 million. Whatever, kilogram over kilogram or gram over gram. Here, gram over gram. I need to use that. Okay, so how much over 500 gram? Okay, I can do that. I can find the answer. So it is I can say it is X is 0.000525. Okay, gram. So this mercury, or Or I can go by conversion. I can do by conversion. Okay, so I want to go from 500 gram total multiple. I want to go to part. Okay, 500 gram total is total 500 gram. Yes. So I write 1 million gram down because I want to cancel total and total, and I want to bring part per million, or so this many gram of mercury equal this and this cancel. So what is the answer? The answer is 0.000525 gram, or I can say it is 0.525 milligram mercury. Okay, in 500 grams of tuna there are this milligram of mercury. Okay, when I should have something really small and in low amount, so I can use this part per million. And when I see part per million, it depends on the question. If in the question is gram, you can use gram. If it's kilogram, you can use kilogram. Depends on the question. And then read the question carefully. Which one is total? Which one is which one is missing? Which one is part? Okay. So here mean level of mercury in fish. Okay, so different kind of fish, they have different amount of mercury. Okay, and that's a mean level, so the mean value. Okay, so mean is average, and you are going to see it in math 270. So salmon, this amount, so lobster, that amount, so tuna, so you can see that. Okay, so halibut is 0.241 part per million. Okay, so this amount even less than 1, but per million. Okay, so 0.241. Okay, so how many grams of halibut must you eat to consume this microgram of mercury? Okay, so from 34.5 microgram of mercury, I need to go to how many gram of total, because it says halibut. Okay, so from here I go to gram of mercury, because one of them microgram, one of them gram. From gram of mercury I go to gram of total. Okay, so I go to gram of mercury, and then I go to gram of total. How do I do this? Conversion factor, which I know what is the relationship between gram and microgram. Okay, how do I do this? Part per million. Let's do it step by step. Okay, 34.5 microgram of mercury. Mercury is part, remember, part, multiple. Okay, microgram of mercury I want to cancel. Okay, is 10 power minus 6 gram of mercury multiple. Now part per million, remember, part per million, that number is part over million is total. So here my part is up and I want to cancel part, so I write 0.241 from the table previous page, so gram okay over 1 million of gram of halibut. Yeah. Okay, so gram of mercury. Oopsie. See, I have microgram of mercury. First, I go to gram of mercury. Then from gram of mercury, I go to total. So I need to use my part per million. But I need to use it in opposite way because I want to cancel this and that. So I need to change the color. I want to cancel this and that, and I want to bring the total amount because it says how much you have to, how many grams you must eat to have that much in part. Okay, so this is left here, this is left here, this is left here, and this is left here. Okay, so the answer is 34.5. So 34.5. That number and that number, they cancel each other. 0.241, which is 143.1. And how about the number of significant? So 3 significant digit, 1 million, because it's definition part per million, that's exact. That's also exact because it's by definition from the table. Okay, so I underline that, check that. It is almost 143.1 gram. Also, no, sorry, just 3 gram of halibut. So if I have that part per million 0.241, so in order to get this amount, okay, part, I need to have this amount total. Okay, in order to consume this microgram of this, we need this gram of that. Okay, I also can do it by proportion, which I'm showing it here. Okay, yeah. Molarity. Molarity is how many mole per liter. So solute in mole per total solution in liter. That gives you how many mole you have per liter. So when you change the solute to mole and then total solution in liter, so that's mole per liter, which gives molarity. Okay, so in this case you need more information. For example, you need molar mass. Okay, you need to know that a bottle in lab is labeled 0.1 m. Capital M is molarity, NaCl. So that's molarity. That's bottle in the lab. The molarity of the bottle is 0.1. Means we have 0.1 mole of NaCl per 1 liter of solution. Okay, so how many gram of NaCl is contained in 3 liter of this solution? Okay, so means I want to go from 3, so I can change the color maybe to blue. I want to go from 3.0 liter of solution to number of grams of NaCl. So I know the molarity is this. Total solution is 3 liter. I want to know the gram of NaCl. Okay, so 3.0 liter of solution multiple. What do I want to do? I want to go to gram. How can I go to gram? Maybe when I have molarity, first I can go to mole, and then from mole I can go use molar mass to go to what I need. Okay, gram. Okay, so from here I go to mole, and from mole I go to gram. So here I need molar mass, here I need molarity. Okay, so 3.0 liter of solution. Multiple. Okay, 1 liter of solution, 0.1 mole NaCl. Multiple. 1 mole NaCl, 58.44 gram of, so just gram as a molar mass. Okay, NaCl. Yeah. So then, liter of solution, mole of this, mole of this. Sorry about my handwriting. And that's gram. That's I have to mention that's gram. Okay, so this is left. This one, this one, this one, and this one. So the answer is 17.5 gram, and I need to go to 2 significant digit because of this. So 2 significant digit. Here is 4 significant digit. Let me see this one here, 0.1. I'm not sure about that. So do we have to, let me see, do we have to, for molarity, do we have to consider it as, maybe because it's labeled and we can consider it as exact. Okay, so, but I'm not sure. Okay, so here, if I give you something like that, so I would tell you how to round it. Okay, so I may say all of the numbers are approximate, then you know how to round it. Okay, so then I underline that, check that it is 18 gram of NaCl. Okay, I need 18 gram of NaCl in 3 liter of the solution, which has this molarity. Okay, so how about this question? So I have 1 here and 2 here, and then I am done. Okay, so a solution contains this gram of NaCl in this milliliter of solution. So this is part, this is total. Okay, determine its molarity. Find the molarity. Okay, so what do I have? I have gram, and down I have milliliter. How can I go to molarity? I need mole per liter. So for top, I go from gram to mole. For bottom, I go from milliliter to liter. How should I do that? For top, I use molar mass. For bottom, I use the conversion factor table that I knew from milliliter to liter. Okay, so 5.85 gram NaCl divided by 5.00 multiple 10 power 3 milliliter of solution. Multiple. Okay, I want to cancel gram NaCl. So 58.44 gram NaCl 1 mole. Multiple. I want to cancel milliliter. Milliliter is down, so I write milliliter up. So and liter here. So milliliter is 10 power minus 3 liter. Okay, so now I cancel. So this and that I cancel. This and that I cancel. So what is left? Mole per liter and all of these numbers. I just have to calculate. So it's 5.85. That's just top divided by this multiple this mole per liter, which is molarity. Okay, so when you find the answer is 0. Okay, let me see how many. So I need 3 significant digits. See here, I have 3 significant digit, 3 significant digit, 4 significant digit, and these are exact. Okay, so here I do this 0 2 0 0 0 0, and let me see, I need 3 significant, yeah, 0 0 2. Okay, so I underline that, check that it is almost 0.0200 molarity. Okay, see, mathematically I don't need to mention these numbers. When I mention, because they are important for me, because I need 3 significant digits. Okay, and make sure to have the sentence. Okay, so suppose that a mixture of aluminum and iron weight this much. Okay, 14.5 gram. So that's a mixture, that's total. Okay, let me see what, okay, that total. So total here, so if there are this mole of aluminum in the mixture, then determine the percentage W by W of aluminum in the mixture. Okay, what do I have here? I have mole top, but for bottom I have gram because that's solution. Just blue, in blue, I highlighted in blue. Okay, okay, so what do I need for molarity? You have to ask yourself, what do you need? What do you have, and how can you go there? How can you find the answer? Okay, so it says percent W by W. I want percent W by W. But what do I have? I have molarity. What do I mean by molarity? So 0.14 mole aluminum. Okay, it's per, so when it's this many mole, so that's per one, let me see, that's per one it says molarity, so mole per liter. Okay, so what do I need here? What do I need? Okay, so I need W by W, percent W by W, so means I need W top and I need W bottom. For W bottom I'm okay because I have 14.5 solution. Okay, so I write this in the denominator, 14.5 solution, gram. Okay, gram solution. Okay, so I try to make the question to pieces, break it to pieces, and then I see, okay, what do I have? What do I want? And how can I find the answer? I have molarity per total gram of solution, the total solution in gram. So I want W by W. So I am fine with the denominator because that must be W. Okay, multiple. I need to just cancel mole here. So I need molar mass. But molar mass of what? Molar mass of aluminum. So I just need the aluminum. So this is extra information. I don't need that. No need. Okay. So, okay, I have to cancel mole and I want to bring a gram. So I write mole down, 26.98 gram of aluminum. See, it says, suppose the mixture is this many gram and there are this many moles. So no, it's not molarity. So it's just this many moles. Yes. So this is not molarity. It says this many moles in it. Okay. So suppose that the mixture, aluminum and iron, weight this many gram. So that's total. Okay, that's total. Then it says, suppose you have this many mole of aluminum in the mixture. So it's not molarity. No, sorry about that. So if I said molarity, no, it's wrong. Okay, so just I have this many mole of aluminum. Then find percentage W by W. Percentage W by W is percent part over total. Both of them should be weight. One of them is weight, total, so perfect. I just need to cancel the part mole and bring gram of part. So mole is up, I want to cancel, I write mole down. And I need to use molar mass, I am using it. And I am done. Okay, so mole of this and mole of this cancel. What is left? This and this and this. Okay, so it is 0.26049, and I need to go to, let me see, two significant digit. Yes, two significant digit because of this. So I have two significant digit, I have three significant digit, I have four significant digit. I can round to two significant digit. Okay, so I underline that, check that, it is almost 0.26. Okay, 0.26 gram, right? Okay, so gram per 1 gram of solution. Remember, if I cannot cancel units, they all stay. So mole and mole cancel, but gram of solution stays, gram of aluminum stays. Both of them stay, so it's here. Okay. But what does percentage mean? This is 0.26 gram per 1 gram. What does percentage mean? Percentage means you can change the denominator to 100 in order to find the percentage. So it is 26 over 100, 26 gram over 100 gram. And that's 26% W over W. Okay? Read the question carefully, always. Just say, what do I have? What do I need? And how can I go there? I have total weight for solution. Perfect. And I need percent weight by weight. So I am fine with the denominator. The top is mole. So I have to change mole to gram. I need to use molar mass. Okay? I use molar mass. Then I find the answer, which is 0.26 gram aluminum over 1 gram of solution. 1 gram of solution. But then I need percentage. So it's 26 gram over 100 gram. Because when I talk about W over W means how many gram per 100 gram of solution. Okay. I didn't want to say this from the beginning because then it was confusing. I wanted you to see this question and then I talk about it. Look at this. Percent W over W means how many gram over 100 unit gram of weight solution. Here, how many milliliter over 100 milliliter of solution. Here, how many weight over 100 milliliter of solution. 100 unit of volume of solution. And you can see this. So when you find the answer in percentage, okay, if the answer is not in percent, then you can change it to percent. So here is 0.26 because it's 0.26 gram per 1 gram of solution. See, when I simplify, this stays. These numbers 0.14, 14.5, 26.98, they all, when I calculate, it will be 0.26049. But what do I have as unit? I have gram of aluminum over gram of solution, which is 0.26 gram of aluminum over 1 gram of solution, and then I can change it 26 over 100. When I have 0.26, that means 26%. W over W. Okay, So here, let me just write this here maybe more neatly. So 0.049 0.49, so gram of aluminum over gram of solution, and then we can say, okay, I underline that, I check that, okay, and then I can find the answer approximately that, and then I can, at the end, I can add a sentence. Thank you so much for your time. I move to topic 12 after this. Bye.